We've been given the answer to a trig function, and we would like to find a few more trig functions. I think about that as trig, trig, triangle. Given a trig, want a trig, build a triangle. Eventually, we will need to know the formulas, the double angle formulas, and I have those down here. But before we get there, we need to do a little bit of pre-work. So let's build that triangle using the tangent of x is equal to -12/5. SOHCAHTOA, tangent is opposite over adjacent. So we're going to build a triangle on what we call the bow tie. The bow tie, see how if I make this shape right here, that is a bow tie. And I'm going to want to build this triangle in quadrant 2 because it says that my x is going to terminate in quadrant 2. So building this triangle in quadrant 2, I have opposite and it's up, so that's why this 12 is positive, and adjacent is left, so the negative is on the 5. When you're creating your triangle, it's important to know that direction matters for the signs. So that original fraction, -12/5, that's what told me to put the negative with the denominator. Okay, then I need to find this missing side, and we can use the Pythagorean theorem, a squared plus b squared equals c squared. So I have -5 squared plus 12 squared equals missing side squared. Once you combine those and take the square root, technically you have positive and negative, but then hypotenuse on these triangles is always positive because it ultimately is the radius of a circle. So I'm going to change that now to the 13 is definitely positive. So the sign of the sides depends on the direction, and the hypotenuse is always positive. Now that we have this information, let's do just a little bit more work. We're going to need to figure out what quadrant 2x is located in, because our triangle is built based on angle x, but we're going to be finding the answer to the trig functions of 2x. Remember the little device here, all students take calculus. In quadrant 1, all trig functions are positive. In quadrant 2, just sine and its reciprocal cosecant is positive. In quadrant 3, tangent and its reciprocal cotangent is positive. And in quadrant 4, cosine and its reciprocal secant is positive. So let's first figure out where x is, and then we'll know where 2x is. I've set up the tangent of b is equal to 12/5. I didn't need the negative sign because I'm just having this free-floating triangle here. I take the inverse tangent of both sides to get the b by itself. And so inverse tangent of 12/5 is about 67 degrees. So this angle measure here is, for b right there, is 67 degrees in that triangle. And so if I want to know angle x, I'm going to take 180 degrees minus that 67. And so angle x is about 113 degrees. Now that I know angle x, I can figure out where 2x is located. Okay, so 2x, 2 multiplied by that 113 degrees is 226. So we know that we're in quadrant 3. That's important because in quadrant 3, one more time, the answer to both tangent and cotangent are positive. So I know ahead of time that the answer to this one is going to be positive, and the answer to both of those is going to be negative. All right. Sometimes visually, you can skip this step a little bit and you can estimate if you know where x is and double it. You could probably tell that we would be in quadrant 3. All right, so now let's get into substituting our values. For the sine of 2x, that's 2 sine x cosine x. And so we're gonna have, oops, 2 times, and then the sine of x, sine opposite over hypotenuse. So if we have opposite over hypotenuse, we're gonna end up with 12 over 13. And then the cosine of x, so adjacent over hypotenuse, that's going to be negative 5 over 13. Let's substitute those values in. And then multiplying fractions, we just multiply straight across. This 2 is over 1. A positive times a negative is going to be a negative. And 2 times 12 times 5 is 120. 1 times 13 is 169. And then I'm just emphasizing the fact that yes, our answer is negative because 2x is in quadrant 3. All right, continuing on here, the cosine of 2x. I have the formula written out here, but emphasizing sometimes this squared messes students up because of its location. Cosine squared of x really means cosine of x times cosine of x, and sine squared of x means sine of x times sine of x. So I want to substitute the answer for cosine of x, looking at my triangle on the bow tie. So adjacent over hypotenuse, we know that that is negative 5 over 13. And the sine of x, looking at our bow tie, so opposite over hypotenuse, is 12 over 13. Negative 5 over 13 times negative 5 over 13 is 25 over 169. Minus, and 12 over 13 times 12 over 13 is 144 over 169. We have a common denominator, so I can combine that. 25 minus 144 is negative 119 over the 169. And then emphasizing one more time, we are in quadrant 3, so I was expecting the answer to be negative. Okay, last one here is the tangent of 2x. There is more than one way to do this particular one, but I'm going to start with just the formula. So if we use the formula, making my substitutions here, and I notice I did rewrite tangent squared of x as just tangent x squared. So 2 multiplied by the tangent of x, looking up there at the given information, I know tangent of x is negative 12 over 5. Okay, then if I multiply 2 times negative 12 over 5, that's 2 over 1. So I end up with negative 24 over 5. And then negative 12 fifths times negative 12 fifths is my 144 over 25. A strategy when you have fractions within fractions, these little mini denominators, what I like to call them, the 5 and the 25. If you think of a number that they both fit into, if you multiply the top and the bottom, all those mini fractions are going to go away. So 25 is a number that both 5 and 25 fit into. So let's multiply the top of the fraction by 25 and the bottom of the fraction by 25. When I do that, this 5 and this 25, you can really think of multiplying fractions by dividing by the bottom and multiplying by the top. So 25 divided by 5 is 5, and 5 multiplied by negative 24 is negative 120. Then 25 multiplied by 1 is 25, and 25 multiplied by negative 144 over 25. 25 divided by 25 is 1 times 144, so we get that minus 144. Let's combine the denominators, and I end up with a negative 120 over a negative 144, but negative over negative is positive. Let's verify that sign. In quadrant 3, 2x is going to be positive for tangent, so we're good. Finally, a little shortcut just on tangent. If you've already gone to the trouble of finding the sine of 2x and the cosine of 2x, I could use the quotient identity. Remember, tangent is y divided by x, or it's going to be sine of 2x over cosine of 2x. And if I already know the answer to sine of 2x and I already know the answer to cosine of 2x, I could just take sine of 2x divided by the cosine of 2x, which happened to have been negative 120 over 169 divided by negative 119 over 169, and I end up getting the same answer.